Audio Jungle. Audio Jungle.
Welcome to another video tutorial. Today, we are going to learn about Boyle's law.
In 1654, Otto von Guericke had invented the vacuum pump. Robert Boyle, an Anglo-Irish scientist, learned of this and was intrigued. He discussed it with Robert Hooke, and the latter made improvements on von Guericke's design. Using Hooke's design and mercury, the two carried out an experiment to vary the pressure on a fixed weight of air. Boyle discovered that when you increase the pressure on a gas, the gas's volume shrinks in a predictable way. He published this discovery of the law in 1662. His findings led to what would eventually be known as Boyle's law, named after Robert Boyle himself. The gas law is sometimes called Mariott's law, or the Boyle-Mariotte law, because French physicist Edmond Mariotte independently discovered the same law in 1679.
Before we start with our discussion, what is Boyle's law? According to Oxford Dictionary, it is a law stating that the pressure of a given mass of an ideal gas is inversely proportional to its volume at a constant temperature.
This means that at a fixed temperature, as the volume increases, the pressure of the gas decreases. Similarly, as the volume decreases, the pressure of the gas increases. Mathematically, Boyle's law can be stated as P is inversely proportional to V, or P is equal to 1 over V, where P is the pressure of the gas and V is the volume of the gas. For comparing the same substance under two different sets of conditions, the law can be usually expressed as P sub 1 multiplied by V sub 1 is equal to P sub 2 multiplied by V sub 2, or P1 times V1 is equal to P2 times V2, where P sub 1 and V sub 1 denote the initial pressure and volume of the gas, while P sub 2 and V sub 2 represent the final pressure and volume of the gas respectively.
We are given with a problem: a balloon with a volume of 2.0 liters is filled with a gas at 3 atmospheres. If pressure is reduced to 0.5 atmospheres without a change in temperature, what would be the volume of the balloon? So what we should do first is we should write the given. We are given with the initial volume, that is 2.0 liters, and initial pressure, that is 3 atmospheres. We are also given with the final pressure, which is 0.5 atmospheres. And we are looking for the final volume. Using Boyle's law, which is P1 times V1 is equal to P2 times V2, we would derive it to V2 is equal to P1 times V1 over P2. We would then substitute the values given. P1 would be 3 atmospheres, V1 would be 2.0 liters, and P2 would be 0.5 atmospheres, which would give us 12 liters. Since we have 1 as the least significant figure, our answer would be 10 liters.
Given the problem, a balloon contains 7.2 liters of helium. The pressure is reduced to 2.00 atmospheres and the balloon expands to occupy a volume of 25.1 liters. What was the initial pressure exerted on the balloon? Based on the problem, we have given of the final pressure and volume 2.00 atmospheres and 25.1 liters respectively. We were also given the initial volume of 7.2 liters and we were asked to find the initial pressure, and which we can solve by deriving the formula of Boyle's law, which will give us the initial pressure will be P2 times V2 all over V1. Substituting our given to our formula, we will have 2.00 atmospheres times 25.1 liters all over 7.2 liters. Cancelling the same units, we will get 6.972 ADM. And since the lowest significant figures is 2, our final answer will be 7.0 ATM.
The given problem is 352 ml of chlorine under a pressure of 680 mmHg are placed into a container under a pressure of 1210 mmHg. The temperature remains constant at 296 Kelvin. What is the volume of the container? So the given is the initial volume of 352 ml and the initial pressure of 680 mmHg. And there is also a final pressure of 1210 mmHg. And we're here to find the final volume of this problem. So based from that, there is given pressure and volume. We're gonna use the Boyle's law for us to get this final volume. So our derived equation is V2 equals P1 times V1 over P2. We're gonna plug in those given here. So 680 mmHg times 352 ml all over 1210 mmHg equals 197.8. Since our significant figure here is, our least significant figure here is 2, we conclude that 2.0 times 10 raised to 2 ml our final volume.
One of the real-life examples of Boyle's law is when we are using a spray can or spray paint or an air freshener. But how? How are these things working in relation with Boyle's law? Let's say, for example, we have a spray paint and obviously there is a paint inside, which is a liquid. Aside from that paint, this spray also contains air. Once we press down the trigger, pressure is also exerted to the gas, forcing the paint to come out through the hole that is at the top of the spray paint. As the paint comes out, the gas is also released, indicating that the volume decreased when the pressure was exerted inside. With the temperature staying the same throughout, the intense pressure is inversely related with the minimal amount of the volume of the gas, which clearly shows that this is an example of Boyle's law.
This mechanism is far more simple than a can of spray paint. Syringes of all types utilize Boyle's law on a very basic level. When you pull the plunger out on a syringe, it causes the volume within the chamber to increase. As we know, this causes the pressure to do the opposite, which then creates a vacuum. When a syringe is empty, the vacuum within the chamber sucks fluid in through the needle.
Typically, when we open a bottle of soda, we slowly turn the cap to allow the air to escape before we completely remove the lid. We do this because we've learned over time that twisting it open too fast causes it to fizz up and spill all over. This happens because the liquid is pumped full of carbon dioxide, causing it to bubble up as the carbon dioxide makes its escape.
When a soda bottle is filled, it is also pressurized. Much like the aerosol can mentioned earlier, when you slowly open the cap, the gas is able to increase its volume and the pressure decreases.
Normally, you can let the gas out of a can or bottle release cleanly. But if the bottle is shaken up and the gas is mixed into the liquid, then you may have a mess on your hands.
This is because the gas trying to escape is mixed into the fluid. So when it does escape, it brings the foamy fluid out with it. Pressure in the bottle goes down, volume of the gas goes up, and you have yourself a mess to clean up.